Hi, my name is Aaron Cosenza, and today I'll be discussing the implementation of data analysis and why it is important in IT communication and data reporting. So, data analysis is the process of inspecting, cleaning, and transforming data and also modeling data. The goal is to discover useful information and suggest conclusions and supporting decision making. Data analysis has multiple facets and approaches, and encompasses diverse and it's under a variety of names. So data mining is a particular data analysis technique that focuses on modeling and the knowledge discovery for predictive rather than descriptive purposes. Some business intelligence covers data analysis uh, that relies heavily on aggregation, focusing on business information. So in statistical applications, some people divide data analysis into descriptive statistics, exploratory data analysis, and confirmatory data analysis. Exploratory data analysis focuses on discovering new features in the data, and confirmatory data analysis is focused on confirming or falsifying existing hypotheses. So data integration is a precursor to data analysis and is closely linked to data visualization and data dissemination. The term data analysis is sometimes used as a synonym for data modeling. So analysis refers to breaking a whole into its separate components for individual examination. Data analysis is a process for obtaining raw data and converting it into information useful for decision making by users. So there are two types of analytics. Predictive analytics focuses on application of statistical models for predictive forecasting or classification, and text analytics applies statistical, linguistic, and structural techniques to extract and classify information from textual sources. It's basically an unstructured data analysis. So data is collected from a variety of sources. The requirements may be communicated by analysts to custodians of the data, such as information technology personnel within an organization. The data may also be collected from sensors in the environment, such as traffic cameras, satellites, recording devices, and it also may be obtained through interviews, downloads, and reading documentation. So data initially obtained must be processed or organized by analytics. For instance, these may involve placing data into rows and columns in the table format for further analysis. So once processed and organized, the data may be incomplete, contain duplicates, or contain errors. This is called data cleaning. The need for data cleaning will arise from problems in the way that data is entered and stored. Data cleaning is the process of preventing and correcting these errors, and many of these tasks include matching, identifying, and kind of like examining the overall quality of existing data. So once the data is analyzed, it may be reported into a few formats for the users of the analysis. The users may have feedback, which results in additional analysis. As such, much of the analytical cycle is basically revolves around the communication. When determining how to communicate, the analyst may consider data visualization techniques or use information displays such as tables and charts to help communicate key messages contained in the data. So there are 6 main techniques for data analysis. The first is check raw data for anomalies prior to performing your analysis. The next is to reperform important calculations, such as verifying columns of the data are formula-driven. The next one is confirming main tools as the sum of the subtotals. The next is checking relationships between numbers that should be related in a predictive way, such as ratios over time. Another would be to normalize numbers to make comparisons easier, such as analyzing amounts per person. And the last would be breaking problems into component parts by analyzing factors that lead to the results. So there are three main challenges in data analysis. The first one is confusing fact and opinion. Effective analysis requires obtaining relevant facts to answer questions, support a conclusion, or test hypotheses. Facts by definition are irrefutable, meaning that any person involved in the analysis should be able to agree upon them. By confusing fact and opinion, you're basically pointing your opinions to fact, and that can lead to inaccurate data analysis, which can throw away all your data and be inaccurate and unusable. Next is cognitive bias. So there are a variety of cognitive biases that can adversely affect analysis. For example, confirmation bias is the tendency to search or interpret information in a way that confirms one's preconceptions. The last is innumeracy. So effective analysts are generally adept with a variety of numerical techniques. However, audiences may not have such literacy with numbers or numeracy, which is called innumeracy or being innumerate. Persons communicating the data may also be attempting to mislead or misinform, deliberately using bad numerical techniques. So basically, there are several free software data analysis users. These are just a few examples, such as DevInfo, which is a database system endorsed by the United Nations Development Group for monitoring and analyzing human development. Then there's ELKI, which is a data mining framework in Java, and KNIME, which is the Constance Information Miner, user-friendly and comprehensive data analytics framework. So here are my references. Thank you for watching this video. I hope you learned a bit more about what data analysis is and why it is important. If you have any questions, leave a comment below. Thank you.